What's up, everybody, and welcome back to this remake of Flappy Bird. This is how we left it in the last part. We got the player controller going, and we got our tunnels spawning from the right, and they will move off to the left, and they should automatically despawn. Which they are, in fact, doing. And of course, all this is using an object pool. So there's no great overhead in doing this indefinitely. Now, what are we going to do today? Well, the first thing I want to do is I want to adjust this control scheme because, as you can see, it's really easy, and Flappy Bird is characteristically hard. So I want to adjust that. I think the camera also is a little bit too close to the player. I feel like we haven't got quite... I feel like I want to pull it back a bit. We also need to add some sort of collision and game over system. We need a scoring system and a way to sort of save the high score. So we've got plenty of work cut out for us. Let us stop here. And what I want to do is I just want to have a play around with the control scheme because I feel like it's a bit too easy. So in order to do that, I'm just going to turn off our spawner for a moment. And we have a spare tunnel in the hierarchy. I'm just going to turn that on for perspective. And let us pull the player... Well, actually, let's get the camera back. Because I feel like it's just a little bit too close. This is going to force us to change a lot of our settings for where the tunnels spawn, but that's okay. So we'll pull that back. I think that's a bit better, maybe negative 15 for the camera. So we just pulled it back a bit, and we will adjust it up to, say, 5.5. Okay, and so what I'll do, let's just click onto the player here. Now we got our player controller. We got our value for force, gravity, and our max threshold height will have to change. But that's okay. So right now, it's really easy just to sort of stay in the right spot. So what I want to do is fall a lot faster. Because if we pull over the original Flappy Bird, let's have another play of this. You fall almost immediately that you stop playing. So it's really... When you push the button, you get almost the same height as the separation between the tunnels. And it takes a fraction of a second for you to fall outside that range. So let us try to improve the speed. So we need to fall faster. So let's try doubling the force. Let's go 60. Okay, that's a bit better. So definitely going a bit faster. But now you don't fall as fast. So let's crank the gravity up a little bit too. And immediately that is a lot better. So I have to push it a lot more. That's actually pretty good. It's much improved. So I need to keep pushing it in a rhythm to stay in the same spot. Okay, I like this a lot better. Let's try turning off the tunnel and turning back on our tunnel spawner. This is immediately much harder. Yes. Yes, much harder. And the gap between the tunnels is probably fractionally too big. And we can also increase the maximum height. So let's do that. But before we do, let's grab our player and just copy that component. Because as soon as I hit stop, it's going to lose those settings. Paste component values. Fantastic. All right. Turn off that tunnel again. Turn on our tunnel spawner. Now the gap range is between, so the gap size is 5. Let's try 3. Ooh, that looks real hard. Let's try 4. Okay, that seems a lot harder. We'll stick with that. The spawn rate's probably a bit quick, so let's crank that up to 3. Which almost seems a bit slow. Oh, that seems about right, actually. Let's go 2.5 for the spawn rate. Okay, I think that's improved. We might work on this a little bit later. The other thing we want is probably a higher gap range. There we go. That's more like what we want. So we want the gap to be potentially up much higher. Okay, so once again, I'll copy that component. We'll stop play and paste those values. So I think that's playing a lot better. Now let's actually think about how we can get the player to lose. So when the player collides with either the ground or the tunnel, we want to trigger some event that will essentially kill the player. The way I might do this is I'm going to create a singleton class that will be our game manager. So we'll create a C# script and we'll call it game manager. And we will add that to a component in the scene. And let's open up that script. Okay, with our game manager class open, what we want to do is create this or turn this into a singleton class. So that way we can access it from any of our other objects, and we know it will always be only a single instance in the scene. So in order to do that, first thing we need to do is define a private instance of game manager. And we will just call it manager. And then what we want to do is create a public game manager called instance. And we're going to create a get method for this. So we will go get. We won't worry about a set method because no other class should really set this. But if they want to get our instance, what we're going to do is first we need to check that this private instance is not null. So we don't want to try and pass along something that doesn't actually or hasn't been instantiated yet. So if manager is equal to null, if it's equal to null, what we want to do is find where in the scene there is an instance of game manager. So manager is equal to game object class dot find object of type game manager. Oop. Add that there. Okay, now once we do that, it should set this manager to whatever instance of game object type manager there is. However, this could still return null. If there's no game manager in the scene, this will not be able to find anything. So if it's still null, so if manager after doing that check is still null, as a matter of fact, we will do this within here. So if manager is still null, what we want to do is basically create it. So we want to create a new object, which is equal to a new game object. Oh, new game object. So just using the constructor class. And I got to define a type here. So we'll just go var new object. And then we will add the game manager as a component. We'll go add component of type game manager. And of course, while we do that, we want to set this instance of manager to that. So, and because add component returns the component you're adding, we can set it that way. So if we can't find it in the scene, we will create an object, we will add it to that object, and then we will set this instance of game manager to be that instance. And then once we've done that, we can be certain that we have a game manager regardless of when anyone or any other component tries to access it. And then we can just go return manager. So that means regardless of when anyone tries to access it, whether they do it in the awake method or at some other time, we can be sure that the manager will exist. Now, what we also want to do is make sure that this doesn't get created several times. So in order to do that, we will create an awake method. Okay, so in our awake method, what we want to do is check whether the manager has been set. So if manager is equal to null, we will set it to this instance. So if this object already exists in the scene and its awake method gets called, it will automatically set itself to the game manager. So manager is equal to this. Now, if this get method is called when there is no game manager in the scene, it will automatically create one and set the instance. So we want to deal with the case of if manager does not equal this version of the manager, we want to destroy this .game object. And I know this is redundant, but I think it makes it more clear to understand. So if the manager does not equal this instance of game manager, we want to destroy it. So that way we can be sure that there's only one in the scene. And that's all we need to do to set up this as our singleton. Now, if you were doing this for a larger scale project, what you'd probably do is set this code as like a base class, and that way any object that you want to be a singleton, you could just inherit from the base class. But I'm not going to worry about that in this particular game. So the game manager is going to keep track of when the player dies and what the score is. Now, you may want to separate this functionality in a different game, but in this particular instance, we're going to just use the game manager to do all this. So first thing we want to do is deal with the player dying. Now, we can trigger that when it touches the collider, so we can add a function for that. Let's do that now. We'll start with the ground, and we'll create another C# script, and we will call this collision trigger. And we don't need start or update. So the Unity function we do want, however, is on collision enter. And what it's going to do is when the object this is attached to detects a collision, it will provide the collision, which will have information about the game object. So what we want to do is test whether that object is the player. And so what we will do is we will go if other.collider.compare tag is equal to the player, we will say game over. Now, what is game over going to be? Well, let's go back to our game manager and we will set that up. So what we will do is actually create I'm just thinking what we'll do. There's a few ways we could do this. I think I'm going to create a public event, and is it Unity event? Yes, so Unity event, and I got to add the using tag Unity engine.events. And what this is really just a wrapper for delegates. It makes using delegates a little bit nicer at the cost of some performance. But again, in this game, we don't care about performance. So public Unity event, and we will call it on player death. And the reason I'm going to do it this way is because we want a lot of different things to happen when the player dies. We want the player to obviously lose control, so that way they can't keep flying. We want the UI to pop up, and we want the tunnels to stop. So we have all these things that we want to have happen on the player death. And so by adding a public Unity event to the game manager, all of those objects can subscribe to that event and then have methods called when that happens. So that way they're all communicating, but without needing any references to each other. So we'll go back to our collision trigger. And so what we want to do is go public, so our game manager. And so this is how we access the singleton, game manager dot instance. Oh, you know what? I've made a boo-boo. I made a big boo-boo. Let's go back to Game Manager. The important part I forgot is to make this a static reference. So static, and we'll make this also static. Okay, so static just means that this bit of data is referring to the class, not so much the instance. And the reason that we need to do that is so that way when I call just the generic class, it has the property of instance. And what I can then do is go on player death, which is the event that we defined. We can go invoke. When the collider hits the player, then it will invoke the on player death event, which other objects will soon subscribe to. In fact, the first one we might subscribe to is the player controller. So I'll jump back to the player controller, and I will have a private bool, I think is the way we'll do this, and we'll just say player is alive, and we'll set it equal to true by default, and we'll say if player is not alive, just return. So essentially what I'm saying here is on the update loop, if the player's not alive, don't call anything else. If the player is alive, then just do this force. And of course, we need to, in order for that to change, we need to subscribe to the player death. So we'll create a private void, and we will call it on player death. And in this method, we will just set player is alive is equal to false. Not force, but false. And then what we need to do is in the start method, we need to subscribe this method to that Unity, to the event. So I'll do this in start, not awake, because I know that the singleton is set up within the awake method. So I don't want to do that in awake. And we don't need it in the awake. Game manager dot instance dot on player death, and we will add a listener, and the listener will be on player death. So in the start method, we're going to start listening to this event, and when this event is triggered, we will call this method here, which will prevent us from actually controlling the player anymore. And I think that should all work at this point. The thing that I am missing is this probably needs to be set up, because right now it would be null by default. And so in the awake method, after we've checked the instance is valid, we will go on player death is equal to new Unity event. And we need to call that in awake because other methods are going to start listening in the start. So we need to make sure that's set up. And with that, if we jump back over into Unity, and we'll test this out on the ground, I will add out collision trigger. And this is indeed set up fine. We just need to make sure that player has the tag, which I imagine I didn't do. There we go. So the player is correctly tagged. So let's hit play. And I have control, and then if I touch the ground, I now no longer have control because the game is over. As a matter of fact, what we might do... No, we'll leave it at that. I was going to say let's freeze the player in the air, but we won't do that. And then what we also want to do is we want the tunnels to stop. So we can open up our tunnel controller. And we want to do the same thing that we did with the player controller, and that is create a private method for our event, and we'll go on player death, and what we'll do is we'll just say speed is equal to 0. And of course, we need our start method to start listening to that event from the game manager. .instance.onPlayerDeath .add listener, and we will add onPlayerDeath method. So that way the tunnels will stop, the player will lose control. Let's quickly test that. So that's only when I touch the ground. Oh, it didn't happen as I expected. So the tunnels are still going, despite the event being called. What did we forget? Well, it looks fine. Oh, it worked that time. I don't know. Oh, I see. Okay. So that only stopped that instance. I know what we'll do. We need to stop the spawner as well. So let's go tunnel spawner. And we need to do the same thing over here. And what we might actually do is go private bool player is alive. And we will set that to true, sort of by default. And then what we can do is come down to our infinite while loop and set that to is true. So as soon as the player is no longer alive, we can stop that our coroutine from spawning tunnels. And of course, as before, we want a on death method. So private, we'll add a listener, void on player death. Now this may seem very, I guess, repetitive and a lot of code for what we're doing. There are, I guess you could say, easier ways than creating an event system and listening to the event system. But what this allows us to do is separate our classes out so that we don't have, what you want to avoid is having your classes requiring references to each other. In this particular case, all the classes are just subscribing to an event. And so if I wanted to change how that event gets called, I don't have to worry about going into every class to update their methods. So this is a pretty good strategy for keeping everything separate and segregated. And of course, we need to subscribe to that event. So game.instance.onPlayerDeath.add listener. And we will add the onPlayerDeath. Now, one thing you could do is you could turn this onPlayerDeath into a interface and then just have all the classes that need to listen to the player's death have an interface. I'm not going to worry about it this time, but that is a strategy that you could help to sort of reduce the code that you're writing, since it will automatically populate your class with that code. Okay, so now the tunnel spawner, they should stop spawning and stop moving. So our tunnels are coming, and we stopped. Oh, but our spawner had one more crack at it. So it was waiting for the spawn rate, and it spawned the next tunnel before the event got called. So what I might do, yes, okay, a better strategy is we'll get rid of this player is alive Boolean, and we'll return our while loop to its infinite state. And what we can do is we can stop all coroutines on this class. So stop all coroutines, and that will just stop this coroutine effective immediately. So let's give that a go. All right, that's working, and we stop. No more tunnels spawned, and everything came to a dead halt. All right, I'm happy with that. Now, the other part that we obviously need to do is add our collider script to our tunnels. So we'll go to the tunnel prefab, and we'll go collision trigger. And so now when we collide with the tunnels, we should get the same game over effect. Ooh. Oh, okay. So it just very slowly falls. I guess because there's friction? We could probably stop that if we come to the player rigid body. We would have to create a physics material, wouldn't we? Let's do that for a moment. So we'll see if we can stop it from sliding down slowly like that, just because it looked dumb. Not that it really matters. So we can come in and we want to create a physics material, which is located on this list somewhere. There it is, physics material. And we'll call it no friction. And essentially what we'll do is we'll come up to where these values of friction. We'll just say 0, 0, and this doesn't, I don't think it even matters. And no bounce. So when we come over to the player, we can come over to not the rigid body, which I always think is counterintuitive. We'll come to the collider, and we should just be able to select our no friction physics material. We'll do the same thing with the tunnel. I'm not sure whether that is necessary, but we'll do the same thing. So no friction on both the tunnel and the player. And we'll see whether that stops that weird slide down effect. Still there a little bit. I'm okay with it. We'll leave that for now. Now that our player can effectively die, what we want to do now is add the scoring system, so that way they have a reason to live. So if I pull over Flappy Bird again, I'm pretty sure the score counter goes up when you get in the middle of the tunnel. If I was better at this game, this wouldn't be a problem. Yeah, so somewhere in the middle of the tunnels, we have our score. So the way our score increment. So the way I think we'll do that is we'll add a invisible trigger to the gap. So that way when the player passes through it, it should trigger a increase in the score. And we know exactly where that gap is because our tunnel spawner is based on it. So all I need to do is create a plane, or probably a quad. Plane is fine. We'll just reset that for a moment because it's really far away. And we will orientate this the right way. Oh. Orientate it like so. And what we'll do is we'll come to our collider. We need to make it convex in order to make it a trigger. So essentially it's just going to be like a box. And what we actually want to do is add, funny enough, we want to add our tunnel controller to this. Tunnel controller, not collector. And our speed, I think we set was 5. That should, when the player passes through it, should trigger the an event. Well, it will in a moment. So let's make this taller and wider. We'll just make this bigger. It probably doesn't need to be that thick. In fact, we'll make it very thin. So it should be pretty hard for the player to miss it. And what we'll do is we'll turn this into a prefab. We'll call it score trigger, I guess. That'll work. And so we'll click on our tunnel spawner for a moment. So we want to use the same spawner, but we're going to need a different pool to handle our score triggers. Decisions. Another strategy could be to put this on the tunnel, but the problem, I'd be worried about triggering it twice since we have 2 tunnels. Okay, so now that I think about this, we're going to have to make some modifications to our object pooling system in order to be able to spawn both these things. Because I want the same spawner to handle it, so we don't want 2 spawners. But we're going to need 2 separate object pools. So in order to do that, I'm going to come in here and I'm going to add our object pool to be visible in the inspector. And we'll just rename it to tunnel pool. I never worry about formally serializing things. And we'll create another one, which will be private object pool, and it will be score trigger pool. And we'll get rid of this start get component for the pools because we're going to set them in the inspector. And what I'm going to do is then create separate objects for our pools. I'm not entirely convinced this is perhaps the best way to be doing this, but here we are. And we'll go object pool on the... If you have a better way to do this, please write a comment below and let people know. So here we'll just go trigger pool, we'll add our score trigger, and our tunnel pool, we will add our tunnels. And then into our spawner, we want to remove the pool from that object. Because it depends on it. So sorry, we got to go back and get rid of this require component tag before we can actually make our modification here. So remove component, and then we have to set the pools individually. And make sure I get them the right way around. Now, we will come here and we'll create a trigger, score trigger, and we'll get is equal from score trigger pool dot get from pool. And then our position for the score trigger will just be score trigger dot transform dot position will equal new vector 3. And it will be actually equal to the gap position. So, or we'll set it to the X position will be off to the right. The Y will be our gap position. Oh, it's just gap position. Gap position and then Z position. I think that works. Now, the thing I want to just check is, does the object pool... No, it does not. I wanted to check whether the object pool changes the rotation of the object at any point, because if it did, that would be a problem for our trigger. So let us see if that works. Making sure not to die now. There we go. So now we got our trigger spawning with our tunnels right in the gap. And so what we can do now, go to the score trigger prefab and turn off the mesh renderer. So that way it's invisible. And now we just need to add our score trigger, so as a script. Now we already have a collision trigger script. So if we open that up, this gets called on collision enter, but because it's a trigger, this is actually not going to get called on our score trigger objects. So, but we could use the same script and just call on trigger enter, And we'll go if other dot compare tag. So if the collider that we've hit is indeed the player, then what we want to do, we want to increment the score. And in order to do that, we need to have our score saved somewhere. So I'm going to do that in the game manager. Okay, so to implement the score in the game manager, we'll just go private int, and we'll just call score. And we will have, I don't think I need those for now. So we'll just create a method called public void, and we'll have adjust score, and we'll have an int of adjustment. And so we will go score plus equals adjustment. I can't see any reason why we would ever do a minus or anything, but this will just give us some more flexibility, I guess. And so obviously in awake, we'll set the default to 0. We don't really need to do that. It's a bit redundant. But it helps my brain by knowing that's 0. Fantastic. So now that we have that method, we can come over to our collision trigger, and when it collides with the player, we can call game manager dot instance dot adjust score, and then we will pass in a value of just 1. So we need a way to visualize our scores. So let's set up the UI. And to do that, we will create a canvas. Create a canvas. Now, what are our settings? We'll go screen overlay. We'll scale with screen size, and I'm pretty sure this is what I have written down as sort of the default resolution I use for phones. So not that we're actually going to publish this on the phone, but we'll set that to be our resolution. And if it goes smaller, then the canvas scale will handle that. And I usually set this about halfway. Okay, so that's our canvas set up. And so we just need a simple Text Mesh Pro. Now I have to import it. Let's go samples and extras because it has a font that we will use. And so here's our Text Mesh Pro object, and we'll call it, will just be the score text. We will center it, and sort of, yeah, we'll go 100 pixels. We might auto size actually. And what font will we use? Let's bring this down. I think there's, I think we'll go with this Electronic Highway for now. And in terms of size, we'll set the width. We'll set it at the top, and we will set it to be the full width. And then the height, we will just scale. And of course, the auto size, this part always bothers me with the Text Mesh Pro. The auto size has such a small maximum. Let's go set it to 200. Now that's obviously probably going to be perfect. It's not too bad. We might give it a bit of a distance from the top. But of course, this isn't going to update by itself. So what we need is a way to control the UI. So we'll create a C# script called UI controller. This will handle the game over screen as well. So let's open that up. Now we need a reference to the Text Mesh Pro. So object. So our score object. So we'll go serialize field, and we'll go Text Mesh pro UGI is what we're after, because that's the actual text field that we're going to be changing. And we'll call it score text. And it bothers me that I didn't write private. Not that it matters, but it bothers me. And did I spell controller wrong? I did spell controller wrong. But that's how it's going to be for now. Score text. Perfect. So when is it going to update the score text? Now, I could do it every frame and have it checked, but that's a little bit silly. There's no need for it to check every single frame. We really only need it to update once the score updates. So go to Game Manager, and we'll create another event, public Unity event, and we will call it on score change. And we will invoke this in our adjust score method. So we'll go on score change dot invoke. I could set up like a public sort of property for this, and when the property gets set, call the event then. But given that this is the only time we're going to adjust the score, we can just have the event trigger in here. And we just need our... Oh, oops, almost forgot. Make sure that this event gets created. So on score change equals new Unity event. Jump back into our UI controller. And of course, we need our method that gets called. Private void on score change method. And what do we want to do here? Well, we just want to set the score text to be the actual score. Now, where do we get that score from? Actually, what we could do is we could make this smarter. I was just going to reference the game manager, but let's be a little more technical and go back to our on score change Unity event. And what we'll do is we'll make a type of int. And so what this means is that our Unity event, or this event, must implement the integer. So it's giving me a little error here. It says it's been invoked, but with 0 arguments. So we just want to pass in adjustment. No, we don't want to pass in adjustment. We want to pass in the score. So when this event gets called, it will pass through this integer. Okay, so Rider's giving me this error that I can't create a new Unity event of type int. And I kind of forgot about this part, which I've never liked. So you can't create a Unity event that takes in a generic type or any kind of type. So what we actually need to do is create another class. I'm just going to do it here. We just need to define, it's basically going to be an empty class, public class, and we'll call it my int, or we'll just call it int event. And it will inherit from Unity event of type int. And rather than instantiating a new, I think we need to make this system.serializable as well. Could be wrong. So what am I going to do in this class? Nothing. That's just, it's almost just defining that the class exists. And rather than going on new Unity event, we will call it an int event. So we'll create a new instance of that class, which just inherits from the Unity event of that type. I don't know why we have to do it this way. That's one of the downsides of Unity events. But that will work just the same, and now we just have this bit of defined class down here. And then now it'll work exactly the same way. So when I come back to my UI controller, we actually need for it to take in a score. And we will come up here to start, and we will go game manager dot on instance dot on score change dot add listener, and we'll pass in on score change. and so it will automatically pass in the score. And so this then becomes score text dot text is equal to score. Obviously toString. I think that's everything. Let's suddenly give it a try. We need to add our UI controller here to our base canvas and just drag in the score text. Okay, let's see if this works. It'd be great if I could do this. Okay, we made it through twice, so that should have triggered the score, but obviously nothing changed. So let's just see what the problem might be. Let's go to Game Manager, and let's have a look at, change to debug mode, and we can see the score is 0. Let's put us, so that means this is not being triggered. Did I actually add this? Okay, that might explain it. So we never added the trigger to the collision object. So let's try that again. Damn it. So let's just cheat a little bit here. Let's go to the player. And we can see, yep, every time we go through, the score is indeed increasing. If only I was better at the game. So let's see if I can actually do that properly. Nope. I'm awful. I'm also noticing that the player falls really slowly when we die, and that's because we stopped the extra gravity from kicking in. We may go back and rethink that. Oh, wow, this is starting to feel a lot like Flappy Bird. I just can't even get through the first tunnel. All right, 1, 2, okay. Okay, so that's pretty good. We've got our player dying when it collides with the tunnels or the ground. We have our score incrementing. I think in the next part, what we'll do is we'll figure out how to save the high score and probably have a look at swapping out some of these default objects that we've got here for prettier ones, and we'll perhaps add some music and some sound effects. But otherwise, I will see you in the next part. Thanks for watching.